So today we're going to focus on spherical coordinates. So spherical coordinates have 3 dimensions as usual, and they're for the 3D coordinate system. So the 3 dimensions are rho, so this looks like a letter P because it's lowercase letter p in Greek, and also theta and phi. So only rho is a distance. Both theta and phi are angles. So what is rho then? Rho is literally the distance from the pole or the origin. So the distance from 0, 0, 0 to this point. So let's say it's xyz to this point, xyz. So if we just calculate that, you get rho. So let me just write that down. So that's just rho. And then I have theta. So what's theta? Theta is just my angle between, so it's just between the positive z-axis to the positive z-axis and my point. So as you can see, here is my angle theta, and it basically indicates how far my point is from the positive z-axis. And then lastly I have phi. So what's phi? Phi is just basically the distance, no, not the distance, the angle between the point, my point, and the positive x-axis. So in terms of the x and y plane, how far is my point? So this is my point. Let's say, just ignore the z coordinates for now. Let's say this is my point. Then this angle here would be phi, because it's the counterclockwise angle between my point and the x-axis. Well, the positive x-axis. So basically now we have this information about what exactly the 3 dimensions of spherical coordinates are. We should learn how to convert them between rectangular and spherical. So rectangular coordinates are in the format of x, y, z. Yeah, and I wanted to convert them into rho, theta, phi. So firstly, we should calculate rho. Rho is the, well, I say easiest to calculate because we just use the Pythagorean theorem. So how do you use the Pythagorean theorem exactly? So we can visualize, we know that this side here is a 490 degree angle, right? So we have x squared plus y squared is equal to this distance here, so that we can call that r. So we know that x squared plus y squared is equal to r squared. So r is equal to root x squared plus y squared. So that's what we know because we have a right triangle here, and this length is x, this length is y. So basically, if we can visualize this on this 3D coordinate plane, this distance is r. So this distance here is just r. So we can just call that r. And you have this visualization, so you can imagine that this is the right angle, that these two images correspond with each other. This is just a 3D version. So we have the x coordinate and the y coordinate. So and the y coordinate of this point. So x squared plus y squared, and you take the square root of that. That's r. So we have r now, and so this is r. And now we want to figure out. Rho. So rho, we can imagine this is also a right angle. So this is also a right angle. There are still right angles within the 3D coordinate system. So and this coordinate. So we just need r squared plus this whatever length this is to get rho squared, right? So this length is just z because it's just how high up my point goes, right? So this is just z. So I have our first formula. So rho is equal to root r squared plus z squared, because we use the Pythagorean theorem for that. It's just like the right triangle we do in the unit circles and polar coordinates. So r squared is equal to x squared plus y squared, right? So that's just equal to x squared plus y squared plus z squared. So basically, we have theta is, so no, not theta, we have rho is equal to root x squared plus y squared plus z squared. So that's our first formula. Our second formula is, so if we calculate for phi, because phi is easier. So we know that this angle here is phi, and if we just visualize it like that, then we know that phi is just, so phi is either equal to So phi is either equal to, you can say arc sine, so arc sine y over r, or you can say arc sine y over root x squared plus y squared. So that's one possibility that we can use to calculate phi, or in this case, sometimes maybe you don't have y, or I don't know, maybe you only have r and you don't have y, etc. Or maybe you just like cosine more, then you can use, then you know that phi is also equal to arc cosine. So also arc cosine x over root x squared plus y squared. So why is this true, right? So you know that sine, basically you know that sine phi, so sine phi is just opposite over hypotenuse, so that's just y over r. So if you want to figure out phi, you just enter the calculator, you enter arc sine y over r, and r is equal to root x squared plus y squared, right? So you enter y over root x squared plus y squared. The same thing goes for cosine, so an arc cosine. So now we have both rho and phi. We can try to figure out this angle here, which is theta. So this angle here, which is theta. So we can imagine that this is a right angle. So this is the right angle. Let me just try to visualize that. So that's a right angle, and if that's a right angle, and this is also length z. So this is a rectangle, okay? So this is a rectangle. So these two triangles are actually just congruent to each other. So we know that this is z, and this side length is r. Then we know that theta is equal to basically, theta is just, well, you can say it's arctangent. So theta is equal to arctangent r over z. So you can also rewrite that as root x squared plus y squared over z. So that's our three formulas, and the reason here theta is arctangent root x squared plus y squared over z is because we know that tangent theta is r over z, and you know that r is equal to x squared plus y squared, well, the square root of that. So arctangent, this value is just angle theta if you plug that in the calculator. So these are our three separate formulas. So this one, so let me just hide that better. And also this one. So we have our three formulas, and now let's just try to convert a simple rectangular coordinate. So let's try to convert 3, 4, 5, let's say. So 3, 4, 5. So firstly, we write down the formula for everything. So basically, we have the formula here, and we write down the format for the spherical coordinates. So we have rho, and also theta, and also phi. So we have rho is equal to, well, root x squared plus y squared plus z squared, which is just root 3 squared plus 4 squared. That's just root 5 squared plus 5 squared. That's root 50. So we know that rho is equal to root 50, which is 5 root 2. So rho is 5 root 2, okay? So you can just write that first. So 5 root 2. Now we want phi and theta. So we have phi, and phi is just equal to arc sine, either arc sine or arc cosine y over root x squared plus y squared. So we can try to use arc sine, and basically, so we need a calculator for this. So I just search it up. So we have calculator, and we know that arc sine is basically y over root x squared plus y squared. So we have phi is equal to arc sine, so y is equal to 4. And then r, root x squared plus y squared is equal to root 25, which is just 5. So we have arc sine, 4 over 5, which is approximately 53.13 degrees. So there goes our phi. And lastly, we want our theta. So theta is equal to arc tangent root x squared plus y squared over z, right? So root x squared plus y squared is root 25, which is 5, and z is also 5. So we have theta. So we have theta is just arc tangent 1. Because root x squared plus y squared is just 5, and z is also 5. So we have arc tangent is 1. Then we plug that in and we calculate that. Then we basically have theta is 45 degrees. So therefore, our coordinates are for 3, 4, 5. Our spherical coordinates are 5 root 2, 45 degrees, and 53.13 degrees. So this is a video about spherical coordinates and rectangular coordinates and their conversion, and also mainly spherical coordinates and an introduction to them. So I hope you learned something. Bye.